from grade 10. Last year you looked at systems of linear equations. Okay. So a system of equations in general is a set of two or more equations with two or more variables. Okay. And the idea with systems is that as long as you have the same number of equations as variables, the system can be solvable if it has solutions. Okay? The solution to a system is the value of each variable that satisfies all equations in the system. Okay, so last year we only looked at linear equations. Okay, so linear equations would have taken the form y equals mx plus b, like a linear function. Okay, this year we're going to add in quadratic equations. So we may have a system of two quadratic functions. We may have a system of a quadratic and a linear. And we're going to solve those types of systems. And we may also have a system of inequalities as well, where instead of an equal sign, we have a greater than or less than sign as well. Okay, and we'll look at what that looks like in about a week from now. Okay, so let's just take an example from last year, because not only did we look at how to solve these, but we looked at 3 different methods of solving these last year as well. I just want to make one up quickly that's going to work, because of course I didn't really prep this, did I? Okay, so for example, let's say we have this system. One equation is I'm just doing some work off the side. Note to self, make up the system before you just go on the fly, right? Because I could make something up, but I want to make something that's going to have a nice solution, because otherwise we're going to get crazy fractions, right? Which is totally fine, but anyway. All right, so here is one equation. Okay, and the other equation is this. There we go. Okay, so here is our system of equations. And the solution to this system is the x and y value. So it's going to be the solution in this case is going to be two values, one for x and one for y, that for each of these equations makes the left side equal to the right side. That's what I mean by satisfies each equation. When I mean satisfy, I mean the equality holds. Okay? Yeah. That's one strategy, is to solve graphically, and in fact, that's what we're going to look at today. So method 1 is to solve graphically. And in fact, I don't want to do this on the calculator because we'll do that when we actually talk about systems of quadratic equations in a few minutes. Let's graph this one by hand, because let's review how to graph a linear function by hand. Okay? So, you know what? Let's get fancy here. Let me get fancy. Why not? Except my smartboard is not very good, so hopefully I remember. Oh no, I want a picture. Okay, let's take that, stick it over here. And I want to make this a bit smaller. And then I think I can even make it darker so you guys can see it. If I change the properties, there we go. How did I do this the other day? I think it was transparent. Was it this? Does that look better? There we go. Yep. Okay, so you guys can see that a little better, right? Okay, sweet. I was thinking on the fly there. I'm improvising today. I shouldn't tell you guys that, should I? Right? Then I would get away with it. Okay, so when we graph linear functions, what's the easiest form to graph from? Yeah. Okay, so ax plus bx plus c equals 0, that's general form. We could graph from that. We could find the intercepts from that quite easily. It's not typically what most people go to, though, although personally I like to do it. Yeah, we could do that. But does anyone have any other thoughts? Yeah. Y equals mx plus c, slope-intercept form. Yeah. Okay, so let's try that, because that's typically what most people do. Okay, so to graph in slope-intercept form, we have to isolate y. Okay, so if I'm looking at this guy, oh, I need to also do that. If I'm looking at this guy and I want to isolate y, that one's pretty straightforward. I just got to subtract 2x from both sides. So I'm going to get y equals negative 2x plus 4. Okay, and if I want to do this one, right, x minus y equals negative 1. Okay, well, I could subtract x from both sides, and I'm going to get negative y equals negative x minus 1. But I haven't isolated y yet because I've isolated negative y. So I have to multiply everything by negative 1, right? Or switch all the signs. And then this becomes y, and this becomes x plus 1. So I have to graph this, and I have to graph this. And by the way, if you were doing this on a calculator, you'd have to take this step anyway, right? Okay, so let's say I want to graph the first one, y equals negative 2x plus 4. How do I start that? Let's see if I can make this a bit bigger. That's a bit better. How do I start? This is in slope-intercept form. Where do I start? Yep. The y-intercept. The y-intercept for this first one is? Yep, 4. So here's 4. So I'll put a point there. And then where do I go from there? Say that again? Okay, so if you made x 1, Then you like make a table of values. Okay, you could totally do that. That's, however, the strategy that you would have used in grade 9. Okay, so let's think about what we did in grade 10. How can we use this value? What does slope represent? Yes. Rise over run. Change in y over change in x. So if my slope is -2, that's the same as -2 over 1. So to get my next point, I've got to go, my rise is -2, which is down 2. My run is 1, which is right 1. Does that ring a bell? Okay, so I go here. My next point is down 2, right 1. Down 2, right 1. I think I messed this up. Oh, no, I didn't. Never mind. Down 2, right 1. Down 2, right 1. Okay, so here, or the other way of thinking of this slope is it's 2 over -1. If you think of it in that sense, then it's up 2, but left 1. So now I'm going up 2, left 1. That's going in this direction. Okay, so here is my line. There we go. Okay, that's the first one. What about y equals x plus 1? Where do I start? What's my y-intercept? 1, so that's where I'm going to start. What's my slope? What's my m value? 1. Okay, or 1 over 1. So I've got to go up 1, right 1, up 1, right 1. Okay, so up 1, right 1, up 1, right 1, up 1, right 1. Or if you want to go in this direction, down to the left, you could think it's -1 over -1, which is down 1 and left 1. And then your points go this way. Okay. Now the point that lies on both graphs, which is this point over here, is the solution to the system, because it satisfies both equations. Now, how would you check? How would you verify?
Please excuse this interruption. In 1 minute, we will be having an important announcement from our constable. Please stay tuned.
Just want to see if I can pause this screen recording. I used to have a little thing that popped up that allowed me to do so. Nope, not going to be able to do so. I'll have to stop this and start again. How do we verify, if we've got this solution to the system, how do we verify that it's correct? You stretching, or say that again?
Plug in X.
Yeah. Plug it into the original equations. So if you have manipulated the equations in any way, as we did here where we isolated y, don't use these ones, because if our mistake was in isolating y, then plugging in that solution isn't going to find that mistake. Okay? So plug into the original equations. Okay? So our original equations were x minus y equals 1. So x minus y equals 1. Okay, so this side is just equal to 1. If I plug in the point, what was it, 2, 1? It was 2, 1, right? So this would be 2 minus 1, and that's 1. Left side equals right side. That's good. Okay? Yep. Nope. Not the original. Oh, shoot. Oh, I did. Oh, that's right. It's, I did the intercept wrong. This is not 2, 1. This is, what point is that? 1, 2. Thank you. There we go. That's better. You're right. This is negative 1. So this should be negative 1, and this should be 1 minus 2, which is negative 1. There we go. That's better. Okay? And then the other one was, let's get this correct, 2x plus y equals 4. All right. 2x plus y equals 4. And I'm plugging in the point 1, 2, right? Whew. Okay. 2 times 1 plus 2. This side should be 4. This is 2 plus 2, and that's 4. So these two are equal. That's what I want. Okay? That's how I verify. Okay. Now, I want to go through the other two strategies. We're going to use the exact same system to solve 3 ways so that we don't have to keep verifying, and then we know what the answer should be and why things work out the way they do. And then we'll start to talk about systems that involve quadratic functions as well. Okay? So the other 2 strategies to solve were algebraic. And these are in no particular order. But I'm going to talk about this one first. This one's called substitution. And in substitution, the idea is that we isolate one variable from one equation. So let's start with the same system. It was, okay, I'm going to get this right this time. X minus y equals negative 1, and 2x plus y equals 4. Okay? So in substitution, we isolate one variable from one equation. Doesn't matter which variable, doesn't matter which equation, but we've got to isolate one of the 4 variables from one of the 2 equations. So let's say I do x from this one, because that's pretty easy. I usually pick the easiest one. Okay, so I'm just going to isolate x, I have to add y to both sides. Okay, so negative 1 plus y. Okay, and the reason why this is called substitution is that once you isolate one variable in one equation, you are going to take this and sub it in for that same variable in the other equation. So I'm going to take this, put it in there. Okay, so let's do that. That's the substitution part. So instead of 2x, I'm going to have 2 with a set of brackets plus y equals 4. And then inside the set of brackets, I'm going to have a negative 1 plus y. And now what happens is I have an equation that only has one variable. And this I can solve. So I'll distribute. And I have negative 2 plus 2y plus y equals 4. Okay, so negative 2 plus 3y equals 4. Okay, add 2 to both sides, we get 3y equals 6. So y equals 2. Okay, now what we can do is, once you get this, go back and get x. Okay, now to get x, you can use the expression where you isolated x, or the equation rather where you isolated x. That's probably the easiest way to do it, because then you just got to sub in the 2 right there, right? So x equals negative 1 plus y, which is negative 1 plus 2, which is 1. X equals 1. And that's the exact same solution that we got graphically. So we don't need to verify that. But if you were solving this from scratch, then you probably would want to do that. Okay, so that's the second method, is substitution. Maybe I'll do method 3 over here since I have some space. Method 3 is called elimination. And, okay, let me not mess this up again. Now that I did it once, I'm like paranoid that I'm going to do this again. Okay, x minus y equals -1, 2x plus y equals 4. Okay, did I mess up there? No, okay, whew. All right, so the idea behind elimination is that we can add and subtract equations to get a new equation that is also valid, right? So for example, the reason why this works, by the way, is because of this. If I have something like, and this is just a side note, if I have 1 plus 2 equals 3 and 4 plus 5 equals 9, those are both true, right? Well then, if I do this, 1 plus 2 plus 4 plus 5 should equal 3 plus 9. I should get a new equation that is also true. Is that true? Yeah. This is why elimination works, okay? If I have 2 equations that are true, I can add them together to get another equation that is also true, okay? I can also subtract. Like if I did this and I subtracted all of that, I'd get another equation that's true, okay? All right, so the idea behind elimination is that we want to try and add and subtract these together to try and eliminate one of the variables. And the way that we do that is make one of them 0. So is there a way to add or subtract these equations together so that one of the variables will be 0 when we do so? Yeah, what would we have to do? Add them. If I add them, this is going to be 3x. This is going to be 0y, okay? Now, let's say we couldn't. Let's say these coefficients were different. Then what? What would I have to do? Do you remember? Yeah. Yeah. So if let's say I wanted to make the x coefficients the same, I could just double the entire first equation and make this 2x minus 2y equals -2. And then these two x coefficients would be the same, then I could subtract, okay? So sometimes you have to take that extra step where you have to multiply one or both equations by a constant to make the coefficients of the variables either the same or they can differ by a negative sign, okay? In this case, we don't have to do that though because we can just add these. We're gonna get 3x plus 0y equals 3. Okay? 3x plus 0 equals 3, x equals 1. Okay? And then you can use either of the equations to solve for y. Or you could do elimination again, but now eliminate the other variable and solve for y. Okay? So, I don't know, let's use the second one, right? So 2 times 1 plus y equals 4. 2 plus y equals 4. Y equals 2. There's the other one. Okay? And then the last thing I want to talk about before we move on, because this is going to come up today as well, is the fact that not all systems have solutions. Not all linear systems have solutions. Okay? So, for example, and this is best kind of seen graphically. If two lines intersect, you're going to get one solution. Okay. Do all lines intersect, though? No. If two lines don't intersect, what are they called? Parallel. Yeah. So if you have two equations that when you graph them, they are parallel to one another. Oh, that looks really bad. Okay, can you guys pretend that those are parallel? They don't look parallel. I apologize. But I put the two arrows in there, so you guys should know that that means parallel. Okay? Parallel lines never intersect. If those two lines never intersect, there is not going to be a value of x and y that satisfies both equations. So this has 0 solutions. Okay? And then there's a third possibility, which is that the two lines could overlap. They could lie one on top of the other. So here's one line, and maybe I'll do the other one in a different color. Oh, that looks bad too, but anyway. Okay, this is infinite solutions. Okay, so that is about a 25-minute recap of everything that you've seen so far in systems. Okay, so this is all sort of pre-knowledge. What we're going to add in is, firstly, number one, what if one of the equations is now quadratic? What if it's a quadratic function instead of a linear function? Or what if two of them are quadratic? And then secondly, what if instead of having a system of equations, we have a system of inequalities, right? So instead of equal signs there, we have a less than, greater than, less than or equal to, greater than or equal to. So that's the extra layer this here. Okay? All right, so solution to a system is a coordinate that satisfies both equations. Okay, it'll also be this intersection on both equations. Okay, so very easy warm-up. We sort of talked about this already. Example, 2, 4 is a solution to y equals x squared and y equals x plus 2. So how would we show that? Well, we have to plug in those values for x and y and show that the left side equals the right side, right? So if you have y equals x squared, left side, right side, so 4, 2 squared is 4. Those are equal. Okay? For this guy, y equals x plus 2. Y is 4. This is 2 plus 2. Or actually, we don't know if it's equal yet, which is 4. Okay? So here, left side equals right side. Left side equals right side. This has to be true for both equations. If it's true for both equations, the solution to 4 is the solution to the system. Okay? Now, let's talk about this. Let's start out by talking about number of solutions. So firstly, between a line and a parabola. So let's draw a parabola and think about how many times a line could intersect that parabola. If you were to draw a line through that parabola, how many times would it intersect? Yeah, twice, exactly. Yeah, so when we're solving a system that involves a linear equation and a quadratic, there could be two solutions. So although we just verified one, that may not be the only one. In fact, I don't think it is. I think there's another one to that one. Okay, so this is two solutions. Okay, is that the only possibility? Yeah. There could be one solution. What would that look like? One section, okay, yeah. If it intersects, does it have to be the vertex? I know what you mean, yes. Yep. Vertical. Okay. Okay, yeah. Okay, yeah. Down the middle. Okay, so I think you guys all know what it would look like, but essentially doesn't just have to be at the vertex, but it can only touch like that. Does that make sense? It doesn't have to be at the bottom or through the middle, but it can just touch the vertex, the parabola at one point. Okay, so it may only intersect at one point. And in fact, this line has a special name when it only intersects at one point. This is called a tangent line. You don't need to know this now, but if you plan to study either Math 31 or AP Calculus, then you will definitely hear about this kind of stuff. This one, when it intersects twice, is called a secant line. This is called a tangent line, okay? And this is called the point of tangency. But for now, what you need to know is that this would produce one solution. Okay, are these two the only possibilities? Okay, no, what else could happen? Yeah. They don't intersect. So if I draw the same parabola, roughly, if I have a line that looks like that, that's never going to intersect. Okay, so there could be no solutions. Correct. Okay, so number of solutions in a system that includes a quadratic and a linear equation, you could have 0, 1, or 2 solutions. Okay? What about if we have two quadratic equations, if we have two parabolas? What could happen there? So I'll draw one. If I were to draw another one, how many times could they intersect? What's one possibility? Yep. Okay, twice, yep. So something like this. Okay, so two solutions. Yeah. Okay, anything else? Yeah. 3 times, okay. How would that look? Okay. There's one. Yeah? Yeah, so if they're overlapping, you could have infinite. Okay, they could be overlapping. Okay, so infinite. Right? Overlapping. Okay. Anything else? Yeah. 1. Okay, what would that look like? Yeah, if the vertexes are touching. So, and here they would have to meet at the vertex. And in fact, this doesn't have to be one opening up and one opening down. It could also look like this, where one is just wider than the other. Why is this not working for me? Ugh. And that's the point. Yeah. Yes. If they're slightly offset. Touching at one point. Let me think about that. So you mean not at the vertex? Let me think. Can I get back to you on that? I'm trying to think, like, you mean like this? Yeah, I think that could happen. Yeah. They could be tangent to one another. Yeah. Yeah. Okay. Yeah, they could have, I think, one solution. If they have the same, let me think about this. If they have the exact same A value, I think they could have one solution. Yeah. Yeah, that's true. It would have to have the exact same A value though, right? Because they'd have to have the exact same shape. Because if they had different shapes, at one point, at some point, this one is going to intersect with that one somewhere. Yeah, but that's true. But yeah, so that would also be a case of this. So there's actually a couple ways, you guys are right, you're thinking creatively, that you could have one solution. Yeah. Yes. No, you won't have 3 solutions. Because then you'd have to have a third one, right? Yeah. If they had different, yeah, but then you have another parabola in there. Yeah. Okay, but there's one more possibility that you guys aren't considering. Because so far we have 2, infinite, 1. These are all different cases of 1. There's another one. Yeah. 0. Yeah. So if one of them looks like that, and the other one looks like that, you'd have 0. Okay? So there's 4 possibilities. You can have 2, infinite, 1, or 0. Okay? Good so far? Okay, so what we're going to look at over the next couple of weeks are different strategies to use to solve these equations, to solve these systems of equations, rather. And today, all we're going to look at is how to solve them graphically. And what we're going to do today is, although I'm just trying to think. Yeah, I could ask you to do this using by hand if I wanted to, because we've talked about how to graph quadratics, but we'll do it using technology today, okay? So if I asked you to solve this graphically, okay, what would we have to do first? Yeah. Make the y 0? Yes, isolate y. Okay, so if we're going to solve graphically, that's the method that we're going to focus on today, is solving graphically. Okay, so to solve graphically, we need to isolate y in each equation. Okay, so if I'm looking at my first one, x squared minus 6x plus y equals 3. No. Plus 3 equals 0. And I want y to be by itself. Then I might move everything else to the other side. Because remember, y has to be positive. So y is already positive. So I'm going to leave it where it is. Okay? So I'll subtract x squared, add 6x, and subtract 3. Minus x squared plus 6x minus 3. Okay, so these all go away. And I get y equals negative x squared plus 6x minus 3. Okay, so that's 1. And then for my other equation, I've got x minus y plus 1 equals 0. So to isolate y there, what do I have to do? Add 1. Yep. Or add y, rather. Yes, thank you. Plus y. And I'm going to get x plus 1 equals y. So there's 1. There's another. Okay. Now you guys should know how to solve these both by, or how to graph these both by hand, by the way. Okay. We're not going to do that today, but we did this guy last unit. You guys did this one last year, and we reviewed it. Okay, so you could be asked, here's a piece of graph paper. Solve graphically by drawing it by hand. Okay, now remember, you have technology with you. We're not going to take that away. So you could graph it on your calculator and use that to guide your process. But yeah, to graph this, you'd have to complete the square, find the vertex, et cetera, right? For today, let's just pull out our calculators. I'll pull out the Casio too. And we're going to enter both of those equations into y1 and y2. So we'll go to y equals, and I'll clear. And the first one was negative x squared plus 6x minus 3. And the second one was, what was it? Thank you, x plus 1. Okay, and I'll do the same on the Casio. So on the Casio, I'm going to delete that, and it's negative x squared plus 6x minus 3, and x plus 1. Okay, and since I'm here on the Casio, I'm just going to hit F6 for draw. There's one, there's the other. Now on this guy, I have to adjust my window. So it looks like I need to go a bit higher in both x and y. So I'm going to go to my window, and I'm going to make my x max maybe, I don't know, 15. Oh, wait, I want to go back to my window. Ugh. Hold on. And I got to do the same for y. I'll make my y max maybe 15 as well. And I'll draw that. And then you can see the two solutions. Okay? Now on the Casio, to find the intersection points, just like when you were finding max points and min points and the zeros and all that, hit G solve again. And you're going to hit F5 for intersect. Okay, and it gives you 1, x equals 1, y equals 2. If you want the next one, you just hit the arrow to the right, and there's the other one, x equals 4, y equals 5. Pretty easy peasy, lemon squeezy on those calculators. Okay, so that's the Casio. On the TI, oh, whoops, where's my TI? Here it is. Okay, I'm going to hit zoom standard. There's 1, there's 2. Now here, to figure out anything that I want to know about the graph, I have to go to second trace to get that calc menu. and I'm going to hit number 5 for intersect. Okay, and it's going to ask me to get close to it on the first curve, to whatever intersection point I want to find. So I'm just going to find this one down here first. So I'm going to move my cursor close to it on my first curve, and I'll hit enter. And then it'll just hop up to the second curve, and usually it's pretty close to the intersection point as well. So I'll hit enter again, and it'll say, do you want to guess? And just hit enter. And then it gives me the intersection point of 1, 2. Okay? So actually, let's do a little sketch of that in our notes. Okay, so when we graph this, we get something that looks like this. And then that guy, if we find that intersection point, I think it was 4 or 5, wasn't it? But let's find it on this one as well. We're going to do the same process all over again. Second trace 5, and now we have to get close to the second intersection point. Hit enter, 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 and there's the second one. It's at 4, 5. Okay? Okay, now, if I want to verify, I've got to try both points. Okay, so to verify, well, first let's maybe do, you know what, I'm going to need more room to verify because I'm going to run out of space. I'm going to verify over here. So this is the first example. So I'll do the point 1, 2 first. Okay, and my equations were, I'm going to use the original. Okay, do not use the ones that where you isolated for y, because remember, if you made a mistake in that process, then you're not going to find your mistake by verifying the equations where you isolated for y. Okay, so it's x squared minus 6x plus y plus 3 equals 0. So okay, so here's my right side is 0. My left side is going to be 1 squared minus 6 times 1 plus 2 plus 3. Okay, so that's 1 minus 6 plus 2 plus 3 is -5, -3, 0. Okay, so we get the left side equals the right side, which is what we want. And we have to verify the other equation as well. We have to verify 4 things here, because we have to verify each point in 2 equations. So the other equation was, what was it? I can't remember. X minus y plus 1 equals 0. Okay, x minus y plus 1 equals 0. Okay, so 1 minus 2 plus 1. This side is 0. So that's what? 1 minus 2 plus 1 is 0. And again, we get the left side equals the right side. Okay? So what does that tell us? That point's good. Now I got to do the exact same thing for the other point. Okay? Now, to save a little time, I'm going to leave that for you guys to try later. Is that okay? Because I think, do you guys get the idea? Yeah? Okay, so do the same for 4, 5. Okay? But that's the process. Okay? All right, next. Let's try this one. Solve the following system of equations graphically and verify your solution. Okay, so here again, we got to isolate y in each equation. Okay, so we got 2x squared minus 16x minus y equals negative 35. There we go. So I think what I'll do is I'll add y to both sides. So I get the y over here. So I get 2x squared minus 16x equals y minus 35. Okay, and then I'll add 35 to both sides. And many of you will be able to do this in one step, and that's fine too. Okay, so you get 2x squared minus 16x plus 35 equals y. There's one of them. And you may notice in this equation, what happened was that these two pieces of the equation flipped, right? The y moved over here, the 35 moved over here, and the signs changed. Yes? So let's do the same thing over here. Sound good? So this equation is going to become, the y will become positive on this side, the 11 will become positive on this side. 2x squared minus 8x plus 11 equals y. There's the second one. Okay, so this is a system of equations where we have two quadratic equations. Okay, let's see what happens when we graph these. Okay, hold on. I gotta look at these. Okay, so 2x squared, because otherwise I can't remember this stuff. Minus 16x plus 35, that's the first one. And this one was 2x squared minus 8x plus 11. Okay, and then on my Casio, I'm going to go over here. And it was 2x squared minus 16x. And then this one was 2x squared minus 8x plus 11. Okay. Okay, so let's see what this guy looks like. There's one. Okay, and then if I graph this one, there's the other. Okay, so what do you think is going to happen here? How many solutions do you think we're going to have? Yeah. And do you know why that is? How could you tell? Yeah. They have the same A value. So essentially what's happening is they have the exact same shape, but one of them's just moved over a little bit, okay? So if we were to, and in fact, let's actually, what I'm going to do, you don't have to do this on your calculator, but I'm going to look at this window setting, and I'm just going to make my X max a lot bigger, but my Y max really, really big, so that you guys can get a sense of what's going to happen and see as this is a lot larger. Okay, can you guys see how they're not quite parallel, but you're taking almost like it's like taking two rings, right? Two arches, and you're moving one over a little bit. Okay, they have the exact same shape curve though, so they're only going to intersect in that one spot. Does that make sense? Okay. All right, so again, second calc 5. And there we go, enter, enter, enter. intersection point is 3, 5. Okay, and you could do the same thing here. On this one, you hit F5, and then F5 again, and there it is. It's at 3, 5. Okay, so if we draw this one, it looks like this. Oh, guys, I'm so bad at, okay, wait, hold on. I gotta make that look a little better. Pressure's on, okay. I used to get complimented on how good I was at drawing circles. I think I'd be able to extend that to parabolas a little bit. Okay, here we go. That's a little bit better. Okay, and you may want to say 1 point since A values are the same. Okay. Now, verifying that. Again, we need to verify that point in each equation. Luckily, since there's only one solution, there's only one thing we have to verify. So the original equations were, oh brother, okay, 2x minus 16, 2x squared minus 16x minus y equals negative 35. Minus 16x minus y equals negative 35, right? That was 1, correct? Okay, whew. So this one is just negative 35, and we're putting in the point 3, 5. So this is going to become 2 times 3 squared minus 16 times 3 minus 5. Okay, now can I just mention something that a lot of people do in 10C that drives me bananas? This is a pet peeve. People do this, and then they make a mistake somewhere along the way and their answer's incorrect. They plug that in. They don't actually bother to check what that's equal to, and they write equals negative 35, check. And it's like, actually, if you plug that into your calculator, you might see that you're wrong. Okay, so this one is correct because we got the right answer, but make sure you actually go and calculate what that is. Don't just plug it in and say, oh yeah, it's equal to the left side, check, I've got it right. That's the whole point. You verify to find your mistakes, okay? So make sure you do that. And in fact, when I'm marking this in 10C and people verify and they're like, I made a mistake, I know I made a mistake because the left side isn't the right side, and I've gone through all my work and I can't find it, I give them close to perfect marks. Because to me, that shows that they understand the concept. When people make a mistake and they put in verification, they don't even bother to check, and they just said, oh yeah, it's perfect, it's fine, you haven't got the point. Does that make sense? Okay. All right, my rant is done. My rant is done. We're not going to do that, though. We are actually going to make sure that this is equal to negative 35. Okay, so 3 squared is 9. So this is 2 times 9 minus 16 times 3, 48, minus 5. Okay, so that's 18 minus 48 minus 5. That's 18 minus 48 is negative 30 minus 5. Left side equals right side. There. That's one of the equations. Okay, let's do the other one. The other one was 2x squared minus, shoot, what was it? Thank you. 8x minus y equals negative 11. All right. Same point. So this side's negative 11. This is 2 times 3 squared minus 8 times 3 minus 5. So this, we know from over here, is going to be 18. Yeah? Okay. 18 minus 24 minus 5. That's what? 18 minus 29? That is negative 11. Left side equals right side. There we go. Okay? All right. I think I've talked for long enough. I know that today was a little bit longer, but I think it was valuable to do that review of grade 10 at the beginning. Hopefully you guys thought so too. So I'm going to stop now. And